Okay, so somehow we were doing the following kinds of series. 1 over n, we knew that this diverges, and then sum of 1 over n squared, this converges, and then 1 through infinity of this one converged as well. And from these, we can actually draw inferences about many other ones. Like, for example, what do you think about 1 over square root of n? Would this converge or diverge? What's your thinking?
Diverge.
Diverge. No, convert 0. Wait, maybe. It may not.
No. This one, okay, yeah. So the limit of the sequence goes to 0. So just by that, we don't know. Doesn't tell us anything.
One by
Well, you plug in infinity
number.
into
1/4. That would be one. That would be one.
Which one's bigger?
1/4.
1/4.
One.
One.
No,
Yeah.
one-
No,
one
no.
over four.
Square root.
1 over square root of 4.
This is
Sorry.
bigger. This is bigger.
One over
Okay.
two. This is
So
pushing
which
one.
one's bigger?
That
The
one.
bottom.
The bottom one's bigger. I know that this is infinity. So what's this sum?
There's more than infinity.
It's more than infinity. So this summation must be
Infinity
Divergent.
trifecta.
divergent.
Oh.
Divergent. So here's a quick proof. I know that square root of n is bigger than n or less than n? Less. Or equal, right? If it's 1, it's equal. Then if you take the reciprocal, what do you know? Inequality reverses, because if you have a bigger denominator, then you have a smaller fraction. Okay? And therefore, when you add them, this side will be bigger. Right? But what is this? This is infinity. So this must be infinity.
How do you have something bigger than infinity then?
Oh, so infinity is like growing sequence of numbers.
Oh, so you're
So
saying
this is growing without bounds, and this is something that's bigger than something that's growing without bounds. So this too has to grow without bounds. That's what I mean by bigger than
So
infinity.
you're saying like it's growing faster to infinity?
It's growing to infinity faster than this other one. That's what I'm saying. But if you just was asking whether this is finite or infinite, the answer is infinite, because this is bigger than the other side, which is infinity. Okay. All right. So here is what's called the p-test. It's about the summation of 1 over n to the p. And by the way, for a series, it doesn't matter whether it starts from 1 or 2 or 3. If this converges, then even if you replace this by 100, it will still converge. Or vice versa. If this converges, then you can start from 1 and it will still converge, because when you have an infinite series, whether it's going to give you infinity or not depends really on the tail of the series. Or the tail of the series. Okay. So here's what we know. That if p is less or equals to 1, then this will be bigger than this one, which diverges. See, if p is less than 1, then n to the p would be less than n to the first power. Right? Therefore, if you flip it, this will be reversed, so that the summation of this side will be bigger than this one, and since this side is infinity, this must be divergent. So if p is 1 or less, then the series diverges. On the other hand, let's say p is greater than 1. So if p is greater than 1, then we use the integral test. 1 through infinity of 1 over x to the p dx, which can be written as x to the negative p power dx. And I'm writing in this format so I can use the power rule. What's the power rule? You add 1 to the exponent, and what do you put in front?
The inverse, or not
The
the
reciprocal. You put the reciprocal, then you plug in infinity and 1. Now, because p is greater than 1, this is a negative exponent. Negative exponent means that really x is in the denominator, right? So when you plug in infinity, this will give you, if x is in the denominator, when you plug in infinity in the denominator, you get 0. So when this goes here, it will give you 0. And when 1 is plugged in, 1 to any power is 1, so it will be subtracting 1 over 1 minus p. Therefore, this will be 1 over p minus 1. And because p is greater than 1, this will be a finite positive value. Okay? So since this integral converges, what can we say about sigma of 1 over n to the pth power? Converges or diverges?
Both.
Huh?
Both.
No, if the
Oh,
integral converges, then
It converges by the
converges by
by the integral.
the integral test. Okay, converges by the integral test. Therefore, if p is greater than 1, the series converges. Okay. That's the p-test. Okay. Now, it only applies if it's in this form. The starting point doesn't matter. This could be like 2 or 3 or even 100. It doesn't matter. But it has to be of this form. While that seems too specific to be useful, what we can do is we can use other series to compare with this one to draw conclusions. So for example, if I had summation of 1 over, say, n minus square root of n from 1 through, not 1, 2 through infinity. If I plug in 1, then I get 0 in the denominator, so it's like this. So,
Doesn't it matter?
what do you think will happen to this one?
I think it'll converge.
Is this bigger than 1 over n or less than 1 over n?
It's less.
Take these two sums. Which one's bigger?
Oh, the other one, the right. Yeah,
This
the one.
one's bigger. Why? Because the denominator is smaller. If the denominator is smaller, the entire thing is bigger. Right? And this is infinity, so this must,
Less than infinity.
yeah, must be bigger than
Or,
infinity.
sorry.
Yeah, bigger than infinity, so this diverges.
Yes.
So you can have other kinds of series to compare with this p series. So knowing this result is very helpful in many ways. Okay, that's why we need to know this by heart as a result.